Students, welcome back to another exciting week of Stanford Code in Place. We are in week 4 and we are doing Python control structures, whiles and fors and ifs and all sorts of great stuff. I'm your instructor, Mighty CS Man, and this week the problem that's assigned in section is actually this problem, which is the high-low game, and the idea is that the computer picks a number from 1 to 100, and then you have to you get a number, and then you have to think whether it's lower or higher than the computer's answer. And rather than going through that one, I actually like to show students a full example of something slightly similar, but has the very same structure. So I've got a game here that you're all very familiar with, heads or tails, right? The computer's going to guess, and you get a score as to whether you match or not. So let's try this one. It's a little bit simpler. So milestone 1, I've generated I want you to generate whether it's heads or tails. So you think back, well, what do we have that can generate random numbers? Oh, well, there's this import random. And because it says import random, we're always going to start with random. And then there's a function, if you might remember, it's called randint. And there's two numbers here that tell us the start and the end number inclusive. So this will actually generate a random number 0 or 1. I'm going to assign it. Now, a lot of people like to assign it, so hey, let's assign it to x. But is this an x coordinate? No. So let's give it something that is worth explaining. So what is it? It is the computer's guess, or the flip. So I'll actually call it a flip. And I could call it, I like to stick on what the type is. Is it an int, it is stir, whatever. So in this case, it's an int, but I'm actually going to say 0, 1 because it's very specific. It's supposed to be 0 or 1, right? And then just as a test, let's go ahead and print, I'll say computer's flip was flip 01. And let's just try running that. Always try running your stuff. So flip was 0, flip was 0, 1, 1, 1, 0. So it looks like we're doing 0 or 1. Great. So we've got a flip. Now, let's ask the user for their guess. So you think back, gosh, how do we get user input? Oh, there's that function, input. So let's input, what's your guess? Let's say, do you call heads or tails? And for short, a little shortcut, I'm going to actually put H or T, just make it quicker for me to answer. Let's store it into a variable, and this is the user's guess, and let's put stir. Okay, so now we've got a guess. Let's now do milestone 3, which is to compare the two. Now, immediately I've got this problem where, I've got an integer and I've got a string that I'm comparing, and that's, you can do that, you can definitely do that, but it would be simpler if we both had two strings. So I'm going to actually convert this 0 or 1 to a heads or tails. So let's try, we'll check to see, is it a 0? Let's call it heads. So if flip 01 equals 0, then flip, and now I'm going to create a new variable, flip stir equals H. Elif flip 01. Actually, let's just do it. Let's just assume that this is going to work fine. So let's just say else flip stir equals T. Okay, great. And just to test, let's print user's guess was flip stir. Let's run that a couple of times. Okay, so the computer's flip was 0, and we call H. The user's guess was H. Oh, let's say user's guess was, and let's also do computer's guess. And this is actually user guesster. Okay, run that. All right, computer's flip was 0. Do we call heads or tail? Let's call H. And now it says the user's guess was H. So it converted that 0 to an H. And the computer's guess was an H. And the user's guess was H. Let's try it again. Let's do something different. Okay, so now the computer's guess is 1, which is a tails. Let's use the T. Okay, so now they're both T. And now let's show the case where it's wrong. Okay, so that 1 is a T, so let's do H for heads. T and H. So we know that that's working correctly. Okay, let's go ahead and comment that out. And let's go on to the game logic. So question is, did we win? So what are the cases that we win? It's when the user's guess is H and the computer's guess is H, or the user's guess is T and the computer's guess is T. But you notice in both of those cases, the strings are the same. So there's actually only one comparison we need to make now. And again, this is facilitated by having gone back up there and changed the 0 and 1 to an H and T. We can just say if flipster equals user, gosh, I've run out of space here. There we go. User guesster. If that's true, then they match. And if so, we can now print correct. And we want to do something with a score. I haven't introduced a score variable yet, but let's say score equals score plus 1. And let's create a score up here. If it doesn't equal, colon. If it doesn't equal, then let's print, sorry, try again. And we're not going to have to touch a score. But in both cases, let's actually print the score out. So score is, now we can put score in there. So let's try this. Okay, so the computer's flip was 0. So do we call H or T? Well, we know that it's actually a heads, so that's correct. 0, let's call T. This is going to be false. This is going to not be correct. Okay, so that worked as well. Okay, so, oh, you know what? We should really replace this flip-o one with the flipster. Okay. Now, how do we do multiple rounds on this? So when we do a loop, we either have the for loop or the while loop. Difference is, if we know how many rounds we're going to do, then you would use the for loop. Otherwise, the while loop would be a better option. So I haven't told you how many rounds. Sometimes, you could make this code, and this is a great extension, ask the user, how many rounds do you want? Okay. But in this case, I'm going to give you the number of rounds. Let's call it number of rounds equals 5. So now I can put a big loop here. Let's say for round in range of num rounds. And then we just have to indent all of this code. So let's try running that and see what we get. Okay, so let's get it right, and let's get it right. Let's get it wrong. Let's get it wrong. And then the last one, let's get it right. So score was 3. Good. Now the last step is printing the game stats. Well, we're already printing the score, but we didn't tell how many rounds that they actually played. So let's do that. Let's print you won something out of something rounds. So the user score is score. The computer's number of rounds is round. Now, there is a bug here, but let's just run this and see. Okay, so I'm going to get, I'm just going to guess tails the whole time. Okay, so we won 3 out of 4 rounds. great, except we actually played 5 rounds. So what went wrong? Well, it's because, remember that this range here, it'll go from 0 to the number before that. So it'll just go 0, 1, 2, 3, 4. We actually want 5. So in which case, we're going to actually have to put round plus 1 in there. So let's try that again. So I'm going to guess heads the whole time. So that's wrong. This one is right. This one is right. So our score is 2. Right score is 3. Wrong score should stay 3. And so, yes, now it says you won 3 out of 5 rounds. So that's a slightly simpler example of the problem that you're going to have to solve with the high-low game, but it's got all the same parts to it. And so just to review, what are the parts here? Well, you've got to generate some sort of random number. Okay, so that was the random.randint. And remember that the range here is inclusive, as opposed to the for loop, where the range does not include that last number. It's going to go 0 to the range minus 1. So generating random numbers, asking the user for a guess with input, game logic. Now, I simplified this game logic here so that we had 2 strings to compare, and the other problem, there'll be 2 integers, so that's straightforward. But the idea is, if you just look for what are the conditions that is a win, you don't have to worry about what's a loss. Just figure out what the conditions are for a win. And if it's a win, you're going to increase the score. Otherwise, you don't. Print out the score. And then the last thing that I fixed up was that, again, because the range isn't going to give you that last number, I had to increase the range by 1. So good luck with the guessing game. Hopefully, heads tails was a little bit of a help to you. Good luck on your problems this week.